Light travels at nearly 300 million meters per second. For 13.8 billion years, it has never stopped moving. And yet, there are parts of the universe whose light will never reach us. The universe is 13.8 billion years old. Because light travels at a finite speed, we can only observe objects whose light has had time to reach us. That creates a boundary, the cosmological horizon, a sphere roughly 46.5 billion light-years in radius, centered on Earth. You might expect the observable universe to span 27.6 billion light-years. It doesn't. It spans 93 billion. The reason is cosmic expansion. When that ancient light was first emitted, the source was much closer. But in the billions of years that photon spent traveling toward us, space itself expanded, carrying that source far beyond where it started. The light arrived. The source did not stay. The expansion of space is described by the Hubble constant, approximately 70 kilometers per second per megaparsec. That means for every 3.26 million light-years of distance, space is expanding 70 kilometers per second faster. At roughly 14.2 billion light-years out, the Hubble radius, the recession velocity of space equals the speed of light. Beyond that distance, space recedes faster than light can cross it. Light emitted there today will never reach us. Beyond our cosmological horizon, space still continues. The unobservable universe. So, what could be there?
The first possibility is a flat universe.
Imagine an endless grid stretching in every direction. No center, no boundary, no final edge. In a flat universe, parallel lines remain parallel forever. The geometry does not close back on itself. Its curvature is zero. It is flat space, continuing without limit. Space could be finite, but still have no boundary. Think of a person walking straight ahead on Earth. They never reach a wall. They never fall off an edge. But if they keep walking long enough, they eventually return to where they began. A closed universe works in a similar way, not as a surface, but as three-dimensional space, curving back on itself. If you keep moving forward in one direction, you could eventually arrive back where you started. The universe would have a finite volume, but no boundary inside. Here, space has negative curvature. Paths that begin parallel do not remain parallel. They gradually diverge. This geometry is open, and it can extend infinitely. It does not close back on itself, nor is it flat. Its shape is hyperbolic. Even triangles behave differently here. Their interior angles add up to less than 180 degrees. Inflationary cosmology introduces a fourth model. In eternal inflation, the inflaton field never stops expanding globally. Regions of it randomly decay into stable spacetimes, each a separate universe with its own physical constants, its own particle masses, its own laws. These regions cannot communicate. Our entire observable universe, 93 billion light-years across, is one bubble in this structure. The rest is causally unreachable by definition. The cosmological horizon is a fundamental constraint imposed by the speed of light and the age of the universe. As dark energy continues accelerating cosmic expansion, the horizon will shrink over time. Distant galaxies will redshift beyond detection, and the observable universe will become a smaller and smaller fraction of what exists. What lies beyond
is unknown because the data is physically unreachable. That boundary is written into the laws of physics themselves.